welcome back to Chem with Kess, where we'll be discussing some more HNMR symmetry. So I'm going to split this video into two, warning, because I want you to get your practice on. So again, just showing you the ropes here, and then y'all could take off on your own. Will we be done with HNMR after this? No. We have a few more things to learn to put it all together. But again, if you can't get symmetry down, you ain't doing jack diddly squat with the rest of the things to come. Ready? So number 7. Do I have a line of symmetry? Oh, I didn't even put my number of carbons here for you to start this one. So that one has 6, that has 7, and this one has 8. So for number 7, it has 6 carbons, and I want to see all my lines of symmetry. So I could do this and fold this picture over this way. I can have another line of symmetry going like this. Ooh, that's not straight through. And that would fold over now this way. Ooh, that was a little off. And then I could have another way that goes like this. No matter which way I fold this structure, all of the carbons are completely symmetrical. So though this has 6 carbons, it is only going to have one signal because it's fully symmetrical all the way around. So that one was a tricky one. So if there's no groups on a benzene ring, it's only going to read as one signal. Moving down to number 8. Again, it has 7 carbons, but now let's see. This one is specific because now there is a group. That group is a methyl group. That breaks up the symmetry. So really the symmetry goes through here. Now, I have students who will be like, all right, Kessie, you lying because look at, there's 2 double bonds on this side and there's 1 here. I'm going to need you to remember that resonance can take place throughout a conjugated system, so those are rotating consistently throughout. So technically it is moving in a symmetrical fashion inside. So that is a line of symmetry which allows the methyl by itself to be considered 1. This carbon right here has no hydrogens on it. So can we count that one? No. So again, it has 1, 2, 3, 4 bonds. So therefore, it's completely, that carbon is completely full. So therefore, there's no hydrogen there. So that means these fold over each other. So that's B and B, C and C, and then D. So even though there's 7 carbons here, only 4 will read. With number 9, I'm pretty sure you can see that line of symmetry a little clearer now. Let's see if I can get a straight line through here. Close enough. So that being able, to fold over, both of these methyls would be the exact same. So those are my A's. These carbons do not have hydrogens on them. Later on, we'll talk about what they're called. They have a specific name, but I don't feel like mentioning it right now. So those do not have hydrogens on them. So those are A's. This one right here is a unique point. It differs from this point over here because I cannot put a line of symmetry going this way. Then you have both of these are the same, C and C. And then D. So even though this has 8 carbons, it only will have 4 signals. Now it's your turn. Do 10, 11, and 12. And start the next video when you're ready. Make sure you understand symmetry though. It plays a very important part.